Unit 3 is going to be ionic compounds. So every lesson in Unit 3 we're going to be talking about ionic compounds. And today we're going to focus on modeling how an ionic compound forms using Lewis structures. So up first we need to talk about what it means if something is ionic. An ionic compound contains ions. It's called ionic because it has ions with opposite charges. So an ionic compound is going to be made up of a cation and an anion. It is important to know that in an ionic compound, electrons are transferred. So when compounds are formed, there's a few ways they could be formed, and one of them is when the electrons get transferred from one ion to another. Electrons could also be shared between two atoms, and we would call that a covalent compound. But for this unit, we're talking about ionic compounds, so the electrons are going to be transferred. And they're always going to be transferred from the cation to the anion. Remember, cations are positive. Cations are positive because cats have paws. So when we were talking about ions and we say like sodium loses one electron, well, where does that electron go? It could lose that electron and it can give it up to an anion, and an anion can gain it. So when we say like chlorine gains an electron, it takes it from a cation. The other really important thing to know about ionic compounds is they're always neutral. That's probably the most important thing to remember about ionic compounds. They're made up of two ions, but the overall net charge is neutral. That's going to be super important for everything that we're doing this unit. So let's start looking at some Lewis structures. Let's say you were asked to model the formation of the ionic compound between, and we're going to do a bunch of these. Let's start with sodium and chlorine. Ionic compounds are always going to form between ions with opposite charges. So one cation and one anion. Another way we could look at this is we could say that ionic compounds are always formed between a metal and a nonmetal. Sodium is a metal, chlorine is a nonmetal. So first thing we want to do is we are going to model this with Lewis structures. So we are going to draw some Lewis structures. So sodium is in group 1A. Sodium has one valence electron. Chlorine is in group 7A. Chlorine has 7 valence electrons. So there's a few things that you have to do when you are modeling. First, we are going to draw an arrow. The arrow represents the transfer of electrons. Remember we said that electrons are always transferred from the cation to the anion, so that will also be important. When you are drawing the arrow always points from the cation to the anion. So sodium is going to lose one valence electron. Chlorine is going to gain that one valence electron. So what this would look like, what your final answer should look like. Sodium lost one valence electron, so its charge is positive 1. Chlorine started with 7 valence electrons. Sodium transferred 1 electron, so now it has 8. It gained 1 electron. Its charge is -1. The opposite charges is what is going to hold this compound together. Sodium has a charge of +1. Chlorine has a charge of -1, and that is going to attract those two ions together, and it is going to make sodium chloride. If we were to write the ionic formula, it would be NaCl. I have 1 sodium and 1 chlorine. When you are writing formulas, and we're going to spend like 4 days talking about writing formulas of different types of ionic compounds. But get in the habit of whenever you write an ionic formula, the cation always comes first. So it would always be NaCl, it would never be ClNa. The cation always comes first. Notice that we said ionic compounds are neutral. Sodium is +1, chlorine is -1, so together my compound has a net charge of 0. Let's try another one. Let's do fluorine and magnesium. So we can look up fluorine on the periodic table. Fluorine is in group 7, so it has 7 valence electrons. Magnesium is in group 2. So magnesium has 2 valence electrons. We're going to draw an arrow to show the transfer of electrons. Magnesium would lose the electron. Fluorine wants to gain an electron. So look what happens when we draw that arrow. Fluorine started with 7 valence electrons. It gained 1, so it now has 8. Magnesium had 2 electrons. It only lost 1 of them. Magnesium wants to lose both electrons. So what we would have to do is add another fluorine. Now magnesium could lose its second valence electron, and it would follow the octet rule. Fluorine started with 7 valence electrons, and it gained 1 to have 8, so it has a charge of -1. Magnesium had 2 valence electrons. It lost both of them, 1 to each fluorine, so its charge would be +2. And then again, my second fluorine started with 7. It gained 1. Magnesium transferred it, so it now has 8. Its charge would be -1. Again, ionic compounds are always neutral, so look at all of your charges. Magnesium is +2, and I have 2 -1s, so this would still be neutral. +2 minus 1 minus 1 equals 0. Cation always comes first. If you have more than one ion, we're going to add a subscript to indicate the number of each ion. So the way we would write this formula would be MgF2. Let's do 2 more. Let's try lithium and oxygen. Lithium is in group 1. It has 1 valence electron. Oxygen is in group 6. It has 6 valence electrons. The cation always loses the electron, the anion always gains it. We are going to always draw our arrow from the cation to the anion. So lithium lost its 1 valence electron, so that's good. Oxygen started with 6 valence electrons, it gained 1. Right now oxygen only has 7 valence electrons. It wants 8. So in order to get 8 valence electrons, I need to add another lithium. Now lithium can lose its 1 valence electron, and oxygen would have 8. Lithium lost 1 valence electron, so its charge is going to be +1. Looking at oxygen, it started with 6. It gained 1 valence electron from the first lithium. It gained a 2nd valence electron from the other lithium. It gained 2 electrons, so its charge is 2 minus. All right, when we write our formula, the cation always comes first. We use a subscript to indicate the number of each ion. I have 2 lithium ions and 1 oxygen. We could also look at our charges and make sure that we're neutral. I have 2 lithiums, each with a charge of +1, so that gives me +2. Oxygen is -2. So overall, the net charge of my ionic compound is neutral. Let's do 1 more. Let's do calcium and sulfur. Calcium is in group 2, so it has 2 valence electrons. Sulfur is in group 6. It has 6 valence electrons. Transfer of electrons will always be from the metal to the nonmetal, from the cation to the anion. Calcium has 2 valence electrons to lose. Sulfur wants to gain 2 valence electrons. When calcium loses its 2 valence electrons, it's going to have a charge of 2+. Sulfur started with 6 valence electrons. It gained 1, 2. It now has 8. It follows the octet rule. If sulfur gains 2 electrons, it has a charge of 2-. When we write the formula, we always do the cation first. So calcium comes first, sulfur comes second. We would add subscripts to indicate the number of each ion. Well, I only have 1 calcium and 1 sulfur. We don't need to write the ones in. Lastly, check to make sure that your ionic compound is neutral. +2, -2, my net charge is 0.